Now in this set of videos we're going to be talking about the physics of transport, getting from one place to another, whether it's a person or freight. Why are we talking about this? Well, partially it's because this is one of the major sources of global warming and we have to do something about it, just like we have to do with decarbonising energy. But also the physics of transport is fascinating, and transport has a lot of problems, and we're going to try and figure out what are the physics limits to how much better we can make transport. Can we actually make transport faster, less polluting, or are there fundamental physical reasons why that's hard? So let's start off with the global warming argument. So here's a diagram we've seen before. It shows us where the world's CO2 is coming from. And we've talked a lot about power, electricity generation. This is the easiest thing to decarbonise, and that gets us 38% of the way there. Not enough by itself, but we know what to do about this. Solar, wind, batteries, a bit of nuclear maybe. Then we've got buildings. We need cooking, and we can certainly replace gas burners with electric. We can heat our water and heat our buildings and our districts with heat pumps powered by more electricity. So we need more electricity to supply these, but we know how to do that. We can do that. But then that leaves us with the things that are hard to deal with, which is transport and industry. And transport's what we're going to deal with now. So where does the transport emissions come from? Well, here's a breakdown from 2018. It's not that different today. And about 75% comes from road vehicles. Passenger vehicles, cars, motorbikes, buses, taxis, mostly from personal cars. And then freight, trucks, vans, things carrying our supplies around. So between those, that's 75%. So that's the main thing to deal with. And then we've got the harder things to deal with: aviation, planes, and shipping, and then small amounts for rail and everything else. So big things deal with the roads, smaller but still important things and much harder to deal with: planes and shipping. Now, why is this a problem? The trouble is that the transport emissions are rising at about 1.6% per year. Why are they rising? I mean, everyone's saying they're trying to make the world more carbon efficient, and they've all made all these pledges. Well, yes, but part of the problem is the population of the world is getting larger. There are more people, so more people travelling. Also, people are becoming richer. The world is becoming richer on average. China's coming out of poverty. India's growing fast. Africa, at least parts of it, are growing fast. And as people get richer, they want to travel more. The average person in Africa has never been on a plane and probably doesn't have a car. But by the time Africa approaches the income levels of, say, China, a lot of people will have cars. A lot of people will be taking flights. And also there is a problem that increases in efficiency tend to be offset by rising demand. For example, aircraft have become much more efficient in the last 50 years. Does that mean that the emissions from aircraft have gone down? No. As aircraft become more efficient, they become cheaper. Plane tickets become cheaper, so people fly more. 50 years ago, people were not jetting off for cheap holidays in Bali or Fiji. Now they can, because the flights are so much cheaper. This is a good thing. It allows flights not just to be for the rich, but for the working class, which is great. But it does mean the demand for aviation and the CO2 emissions from it just keeps on going up, even as the planes become more efficient. Likewise, cars have become somewhat more efficient. Not they haven't improved as much as planes, but they have improved a bit. But people are buying bigger cars. 30 years ago, the average car in Australia was a small hatchback or maybe a sedan. Nowadays, most people own SUVs and they're monster trucks. So it's going to be hard. Here is a scenario for what might happen from the International Energy Agency. So we've got the data up to the present day with a fairly steep rise until COVID hit. And then what must happen in the future, which is a big drop if we're to keep global warming below 1.5 or 2 degrees. What they've anticipated is the biggest decline being in road vehicles, passenger cars and light commercial vehicles. The medium and heavy trucks declining slower, and aviation and shipping not really declining very much at all. They're going to be very hard to decarbonise. At least they stopped growing and maybe declined a bit, but not too much. So that would be the idea of what we could do. But there are many other problems with transport, not just the carbon dioxide it emits. For a start, it's deadly. About 1.5 million people per year die in road accidents. Down here is the death per billion passenger kilometres for different forms of transport. And you can see cars, it's 2.5 deaths per billion passenger kilometres. You're much safer as a passenger on a bus or a coach, it's 10 times safer. But another 5 times safer still if you're on a railway or a plane. They're much safer than driving a car. But motorbikes, scooters and generally motorised two-wheelers, very dangerous. But in addition to just the road deaths, people crashing in planes and so on, probably about 2 million people die every year due to air pollution from road traffic, more than the people who die from road accidents. This is a graph of where the pollution in major cities comes from in different parts of the world. And black is from traffic. Yellow is unknown. Probably much of it also comes from traffic. And you can see that it's typically 20-30%, something like that. And we know that overall the air pollution around the world kills about 10 million people a year. So we can talk about 2 or 3 million of that being due to road traffic. And in addition to the people who die because of it, many, many more have their kids have their development stunted or live in permanent poor health, coughing all the time. So the toll of the pollution from cars and from everything else is really bad. There's also noise pollution. Most of the noise pollution in cities comes from cars, planes and trains. I grew up under the flight path to Heathrow Airport and we would have to stop all conversations many times a day as planes came over. It causes sleep loss, heart disease and learning problems. Even when you're fast asleep and don't consciously notice the noise, it still raises your blood pressure and heart rate, it turns out. So that's a very bad thing, and most of it's due to transport. And then, of course, transport causes congestion. A typical driver in London, where I grew up, spends 150 hours each year stuck in traffic. In large Australian cities it's not that bad, but it's still about 60 hours a year in Sydney, Melbourne and Brisbane. Cheap transport leads to massive overcrowding in tourist hotspots like Venice, shown here. Now that working class people as well as the rich can travel, and they all want to go to the same beaches or cities, they get absolutely insanely crowded. The speed of transport has not really improved for a very long time. Airliner speeds have not significantly changed since the first Boeing 707 or Comet. A little bit better, but not much. In major cities, transport speeds have not changed in sometimes over 100 years. In London, for example, the average speed's about 12 kilometres an hour at the moment because of the congestion, which is actually about the same as what it was in Victorian times 150 years ago when people took horse and cart around. Highway speeds haven't changed very much. Trains, we have high-speed trains now, but the top speed of a high-speed train, again, hasn't changed very much since the first TGV was introduced in France about 60 years ago. And what a waste of space! In cities in the US, downtown area, about 50% is devoted to cars, whether it be roads or parking areas. All that land that could be parks or have housing on it or something like that, something useful rather than just huge amounts of concrete for cars to drive over and park. So we pay a very heavy price for our transport. So here's an overview of what I want to talk about in this section of the course. First of all, how efficient are different forms of transport? How much CO2, how much energy does it take to fly in a plane, drive a car, ride the train, ride a bicycle? And then we're going to dive into the physics of where that energy actually goes. For example, cars are much less efficient than bicycles. Why? Is there some way we could make them better? How efficient could we make these things? We're then going to talk about decarbonisation options, what can we actually do to make things better, and we're going to talk about can we reduce transport or change it to get rid of the pollution problems, the congestion problems, or just generally reduce pollution by having less of it. Do we really need that many cars and this many planes?